Hello, welcome back. Today let's try to solve another Leetcode problem, 286, walls and gates. So for this problem, we can understand it according to this drawing, example 1. Because example 2 is just straightforward. If there's a -1, means it is walls. We're gonna just return the rooms, our final grid. And now let's check the example. We just need to check the empty. This empty means rooms. So what is the shortest distance? So 1, 2, 3. It means 4 here. 1, 2, 3. It means here is 3. So it means the shortest distance is 3. This is why for this one it is 3. Let's check another grid. For example, this one. It should be 1 because it just go here. Now let's check if it is 1. It is 1. I'm not going to check all of them, but this is just examples meaning. And we also have an infinite. It doesn't matter because this infinite just means empty rooms, and -1 means walls, and 0 means gate. Now, how can we solve the problem? Of course, we think about the BFS. If we use the BFS with brute force, it means from this point we're gonna check what is the shortest distance by BFS. It means we've used how many BFS? M times n BFS, because for each of the empty grid, we need to use BFS. And for each of the BFS, we take m times n time. So finally, the time complexity will be O m square times n square. As you can see, this really takes the time. This is the Python meaning of the square. I just use this sign. But actually we can just use m times n time complexity to solve the problem. Why? Because we can use a multi-source. We don't need to loop through all of them. Use m square, n square time. We just need to use m times n. If we use multi-source, we're gonna start from the gate, not from the rooms. So this is something, you need to think backward, not forward. You need to think from the result and then go to the empty rooms, not directly, but backward. Now, if we use a multi-source, we put we put the gate inside our multi-source, inside our queue and set. After that, we're gonna use the BFS. It just takes OM times n time to update all of the empty grid inside the drawing. For example, here will be updated to 1, 1, 1, 1, 1, and this one will be 2, and this will be 2, this will be 1, this will be 1. I will not put all of them, but you can see the drawing. This is 1, 2, 3, and this is 2, this is 1, 1, and this is 2, 3, and 4. It makes sense, right? Because the drawing is like for each of the grid we need to find, but for us we need to go from the gate and then go to the empty rooms. As you can see that, it's very straightforward. Now let me just start my coding. So for the multi-source BFS, we're gonna prepare some template code. Let me prepare R and C should equal to length of the rooms and length of the rooms 0. Let me prepare a queue with a visited set. The queue should be the queue and the visited set should be an empty set. Now I also need directions. It means I'm gonna have 4 directions. So inside the directions, I'm gonna prepare some setting for my calculation. So 0, 1, 0, -1. This just means 4 directions. And 1, 0, and -1, 0. After initializing all those variables, we can start the first multi-source. We're gonna find the multi-source. So for R in range, capital R, and for C in range, capital C. Here we need a condition check. If rooms are C equal to, let's check the gate, because the gate is 0. If it is equal to 0, it's from here. If it is a gate, so what are we gonna do? We just need to put it inside our queue, q.append with RC, and q.add with RC. This one, we just finished our multi-source because we don't need to update our rooms RC because it already started from 0. And then from the next place, we just use this 0 plus 1 for the next neighboring empty room. This one, for example, this one and this one. Now let's just start our BFS. So for the BFS, we're gonna use a while loop while this q, and RC should equal to q dot pop left. After popping the first node, we're gonna update the RC. So for DR and DC in directions, if let's update the new row and new column should be R plus DR and C plus DC. Now we just need a tag. So for 0 less than, the row less than and equal less than and equal to row less than the R, and similarly for the column should be more than and equal to 0 and less than capital C, and also our row and column tuple not invisited. Yeah, now let me spread a little bit to make it just one line. Yeah, for checking mistakes, as you can see, I have a typo. It should be visited. Now, after checking, if it is not invisited, I don't need to check this numbers, infinite numbers, as you can see, because I used a visited set. Yeah, if it is inside a visited set, it means the gate has already been inside a visited set. But I need another check. I need to check if it is not a wall, and if rooms, row, and column not equal to -1, because this wall is -1. Yeah, if it is not, I can update the q dot append with my new row and new column. Similarly, the visited set dot add with new row and new column. Now I can safely update my rooms. So the rooms with row and column should equal to rooms where am I coming from? RC. Yeah, this RC means from here. It is popped out. Yeah, means this is the RC and this is my neighboring empty rooms. Yeah, plus 1. Finally, I just need to return the rooms. Yeah, I hope there's no typos. Yeah, let's just check if it works okay. Oh, the q add. I use here should be visited set dot add. Yeah, visited set dot add. Let me run it again to check. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast, nearly 72% of all Python submissions. And the code is quite clean. Let me spread it. Yeah, as you can see, the time complexity is just m times n. And for this one, this area is just a template. For any kind of a multi-source problem, we need to prepare this. And we also need to prepare this. This is the basic situations. For us, because the rooms are say equal to 0, we don't need to set it, because it's already started from 0. Even it started from other numbers, it doesn't matter. It's just dependent on the description on the output of the problem. As you can see here, this area is also the template. Here, the only difference is we have a walls. We need to check if it is not equal to -1. But for other normal problem, we don't even need to check this condition. And here is also the template code. There's no other new code, only template. Yeah, thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problem like this, and I will prepare all patterns of the Leetcode problem.